All right, let's look at this problem and we'll try to do it in under 5 minutes if we can. So you still need to calculate molar masses, right? Which takes a little bit of time. But anyway, how many grams of chlorine? So let's start here. How many grams of chlorine can be prepared from the reaction of 16 grams of MnO2 and 30 grams of HCl. I'm not writing 30.0 because you know that 0.0 doesn't matter right now in calculations. It will matter in the end for significant figures. Okay, all right, so that's our problem. Look at the equation. It seems to be balanced, or yes, it is. Okay, we have enough chlorine on every side, so that's good. So which means that since I'm given two reactants, this is a limiting reagent problem, okay? So which means I have to do twice the work, which is fine. I can handle it, and so can you. So let's go ahead and calculate the masses first, which is MnO2, so Mn plus 2 oxygen. And then we'll need the mass for HCl, so H, and then 1 hydrogen plus 1 chlorine, right? And then the Cl2, which is 2 times chlorine then, okay? And so let me just make this better because it looks a little awkward. H plus Cl. Okay, so don't add the 4 in front. Don't multiply that, okay? Not yet. You can if you want to, but then you have to be careful later on, okay? So I don't want to do that right now. I just want to go ahead with what we have. So let's go ahead and do this, which is MnO2. So 54.94 plus 2 of the 16, and this is 86.94. HCl is 1 plus 35.45, and that's 36.45. And then 2 times 35.45. This is 70.9, and of course, everything is gram per mole, gram per mole, gram per mole. Okay, all right, so now we need to set up to form chlorine, okay, over here. So we'll start with MnO2 first, okay, and then see what we get. So we have 16 grams of MnO2 divided by, there's a coefficient of 1 there, right? In front of it, there is 1. So I'll just put 1 there. And then 86.94 grams per mole multiplied by, and the product is Cl2, remember? That's what we are going for. And the coefficient is 1 there as well. And then 70.9 grams per mole. Okay, so that's going to be for MnO2. Let me go ahead and set up for HCl as well, and then I'll do the calculation at one time. So this is then 30 grams of HCl divided by, now I have a coefficient of 4, so 4 times 36.45 times, and again, the coefficient for chlorine is still 1, times 70.9, okay, grams per mole. Grams per mole. And so now we just need to do our calculation, which we will do for the top one, 70.9 times 16 divided by 86.94, and that is equal to 13.05, which really is actually in my calculator is showing as 13.0. Okay, so not even this. Okay, then that's going to be grams of chlorine. And then the bottom one is 30 times 70.9 divided by 4 divided by 36.45. And that gives me 14.6 grams of chlorine. Okay, so the smaller number is the product. So 13.0 grams of chlorine is actually going to be produced because MnO2 is my limiting reagent over here. See how fast that was, okay? I don't know how much time has gone by, but I think it's been less than 5 minutes, okay? Hopefully, let's see. But anyhow, this is how you would do, a problem really quickly with this without setting up big stuff,